Okay, so today we're going to talk about quadratic transformations. Okay, in order to talk about transformations, which means to change, we have to talk about the parent function first. So let's go over the parent function. So the parent function for a quadratic, the parent function is f of x equals x squared. All right. So if you were to make a table for that and graph that, so let's make a table. So that would be, here's x, here's f of x. I'm going to just start with -2. I'm going to go all the way to +2. And if I square -2, I get 4. If I square -1, I get 1. Square of 0 is 0. 1 squared is 1, and 2 squared is 4. So when you graph this on the x and y axis, you're going to see that parabola. So your vertex will be at 0, 0. There you go. And you will see it'll come down like so, curve, and then go back up. And that parabola is that U shape. So there are some critical points, and I do want to kind of bring those to your attention. They're referred to as critical points. I'm going to change the color real quick, okay? So these are your critical points. Your critical points are the kind of points that you're looking for no matter what kind of parabola you're looking at. The one thing you always want to look for is the vertex. In the parent function, the vertex is going to be at 0, 0. So this is going to be your vertex. The other point you're going to look for happens to be right here. So this point is the point 1, 1. Notice that the next point that I can actually see, the next pretty point, is 1 to the right and 1 up. That's really, really interesting. These are critical points. They're points that we look for in every parabola. We look for the vertex, and we look what happens 1 to the right and 1 up from the vertex. We also want to notice critical points. Sorry, I should have wrote the word points. Sorry, got it, points. And then we also want to notate that this opens up. All right, so this is going to be an upward opening parabola. Now that's the parent function. That's your basic parabola. From there, we can make transformations or changes. So let's look at what those changes would be. Let's go back to black. Okay. So let's see here. If you have transformations, you will see that in the equation. So transformations, let me show you what that looks like in the equation. I'm going to put all the transformations in the same equation. We don't always see all of them every time, but I'm going to put them all together so you have something to view. Okay? So if the first thing that you see out of the gate is a negative, that is going to be a reflection. Let me go ahead and write all of these. There we go, and that would be squared plus or minus k. All right. So let's talk about what each of these transformations are. All right. If you see a negative right out of the gate, maybe I want dark blue. Right here, right after the equal sign, we say that that is a vertical reflection. You'll also see this written as a reflection over the x-axis. So you also see that too. So reflect over x-axis. I know that's a weird thing to say, to reflect over the x is a vertical reflection, but that's what it means. This value of A right here, that is a vertical stretch or compress. So stretch, or it could be a compress. All right, if it's a stretch, then A will be greater than 1. If it's a compress, A will be a number between 0 and 1. So numbers between 0 and 1 would include 0.5, 1/2, 3/4. The K, way out here, that is a vertical translation. That's a slide. You'll also see it referred to as a shift with an F. All right? If you have a positive K, that means you're going to shift up. If you have a negative K value, the parabola will shift down. Now let's look at what happens in the parentheses, because the things that happen in the parentheses will all be horizontal changes. So let's look at that. So our horizontal changes, if you have a negative right inside the parentheses right here, that would be a horizontal reflection. You'll also see it listed as a reflection over the y-axis. So you'll see it mentioned as that as well. The B value, that would be a horizontal stretch or compress. And the horizontal is actually going to be, it's going to be opposite of the vertical. So the stretch in this case would be between 0 and 1, and the compress would be greater than 1. And we usually say that this is a horizontal stretch by 1 over B. And we'll talk about what that means. Then here, the H, that is your horizontal translation. A horizontal translation, if it is positive, you actually go to the left. And if it is negative, you actually go to the right. So I do like to think about everything in the parentheses as opposite of what would happen to it if it were outside of the parentheses. You'll also see these transformations happening in function notation. Sometimes they won't write out the whole equation. They'll just give you function notation. So let me show you what that would look like. So if you just have the function notation, you're still going to see a lot of this very similar notation. You would just see it with F and X. There wouldn't actually be an equal sign or anything. All of these transformations are going to be exactly the same. Okay? So everything outside those parentheses is still going to be vertical. So out here, this would still be, if you start with that negative, that means you have a vertical reflection. If you have this A value, that is still going to be your vertical stretch or compress. The rules are the same. If A is greater than 1, it's a stretch. If A is between 0 and 1, it's a compression. And with this K value, you're still going to translate up and down. It'll be plus K is up and negative K is down. And that's going to be a vertical translation. Everything inside the parentheses will be very similar. It'll still be horizontal. So this negative here is still going to be your horizontal reflection. The B value is your horizontal stretch or compress. Remember, it's going to switch around. So the stretch is going to be 0 to 1. And the compress is going to be greater than 1. And your H value is still going to be a horizontal translation. And if you have a positive H, you actually go left. And if you have a negative H, you actually go to the right. Okay? And that's how you would see that in function notation. So take a minute and get that written down, and then let's do some practice so we can kind of see how this notation works in practice, in problems and graphs and equations. Okay? That's it.